I'm going to speak about vitamin C and cancer. I hadn't planned to work on cancer, which I began, in fact, 10 years ago, nor to work on vitamin C or other vitamins as I began around 16 years ago. Instead, I got into these fields by accident or through some concatenation of circumstances that just led me into these fields. I started to work on hemoglobin after having worked on simpler molecules for 14 years in 1936. And then the next year, I began some work together with my students, of course, in the field of immunology. Then in 1945, I had an idea that sickle cell anemia might be a disease of a molecule rather than a disease of a cell. Dr. Harvey Tano, a young physician, came to study with me, and he and I began to check up on this idea. In 1949, together with two other students, Singer and Wells, we published a paper, Sickle Cell Anemia, a Molecular Disease. After being with me 8 years, Dr. Itano was ordered as an officer of the Public Health Service to move to Bethesda. And I decided that I should give up work on the hereditary hemolytic anemias. It didn't seem to me very sensible of me to be competing with such an able and vigorous young investigator as Dr. Itano. So I thought, why shouldn't I look at other diseases to see whether or not they are molecular diseases? And they might as well be important diseases, because nobody else was working in the field, except by that time there were a good number of hematologists studying the hemoglobinemias. I thought, well, I might work on cancer, or I might work on mental disease. And I rejected cancer. For two reasons. One, it seemed to me that it was just too complicated a field for me to be involved in. And second, many investigators were carrying on studies in the field of cancer, whereas in 1954, very few people were working on mental disease. It was the mental disease, our studies on schizophrenia and mental retardation, that got me into vitamins. After about 10 years of work in this field, I ran across some papers, publications by Drs. Hoffer and Osmond in Canada, Saskatoon, Saskatchewan, Canada. They made a report that really astonished me. They said that they were giving large doses of nicotinic acid or nicotinamide to schizophrenic patients. I knew, of course, that a little bit of nicotinic acid or nicotinamide must be ingested day after day, 5 milligrams, perhaps a little pinch, to keep a person from dying of pellagra. So I knew that these substances, the pellagra-preventing factor, are very powerful substances. 5 milligrams a day will keep a person from dying of the disease. And yet, these substances are so lacking in toxicity that Hoffer and Osmond were giving 1,000 or 10,000 times this physiologically effective amount, or pharmacologically effective therapeutic amount, to schizophrenic patients. Nobody knows just how toxic they are. People have taken 100 grams a day or even more without any serious side effects. I thought, how astonishing that there are substances of this sort that have physiological activity over a tremendous range of concentration 1,000-fold or 10,000-fold range of concentration. In fact, I found that Milner had been giving large doses of vitamin C in a double-blind experiment to schizophrenic patients. And he reported that several grams, perhaps 1,000 times the amount that will prevent scurvy in most people, several grams of ascorbic acid is also effective, more effective than a placebo for these schizophrenic patients. Well, the idea that such substances exist, which are effective in one way or another over a tremendous range of concentrations, caused me to decide that this field of medicine deserved a name. I invented the word orthomolecular to describe it. Orthomolecular means the use of the right molecules in the right amounts. The right molecules are the molecules that are normally present in the human body, and the right amounts are the amounts that put people in the best of health. Well, I was interested in infectious diseases in relation to vitamin C originally, but in 1971, Charlie Huggins asked me to speak at the dedication of his new cancer research laboratory. I thought I must say something about cancer. So I remembered that I had read a book published in 1966 by Ewan Cameron, a surgeon in a hospital in Scotland, who had been a general surgeon who had, however, all of his life as a surgeon been interested in cancer. He formulated a general argument in this book, hyaluronidase and cancer. This argument was this. He said, the body has protective mechanisms, the immune system, for example. If we could potentiate these the natural protective mechanisms, they might provide additional protection against cancer. As Professor Deduve pointed out, we have in many patients, most patients with cancer, circulating cells, but not all of them develop metastases. Those whose immune systems are functioning well have a smaller chance of developing metastatic cancer than those whose immune systems are not functioning well. Well, I thought, we know one thing about vitamin C. It is required for the synthesis of collagen. If, then, persons with cancer were to be given larger amounts of vitamin C, they would be stimulated to produce more collagen fibrils in the intercellular cement that holds the cells in normal tissues together. And these tissues might become strengthened in this way to such an extent that, as Cameron pointed out, without mention of vitamin C, to such an extent that they could resist infiltration by the growing malignant tumor. Dr. Cameron saw a newspaper account of my talk and wrote asking how much vitamin C to give. I replied he should give the patients 10 grams a day, 10,000 milligrams, 200 times the usually recommended amount. He began cautiously with one patient in Vale of Leven Hospital, Loch Lomond side, Scotland, and was astonished by the response of that patient to such an extent that he gave 10 grams of vitamin C a day to a second terminal cancer patient, an untreatable patient receiving no treatment other than the vitamin C and narcotics to control pain. And then a third and fourth and more patients as he became more and more convinced of the value of this substance for patients with cancer. I may have started out now with the first slide. Well, I think, and perhaps this is the message that I should emphasize, I think that the people in the field of nutrition, the scientists in the field of nutrition, which up to 15 years ago seemed to me to be a terribly boring subject, have been off on the wrong track. They have said that a vitamin is needed, it's an organic compound needed in small amount to prevent death, by a corresponding deficiency disease. And they have striven very vigorously over a period of 40 or 50 years to find out just how much each of these substances is needed to keep people from dying. I believe that the problem that should be attacked is that of finding the intake that would put people in the best of health, not just the amount that will keep them from dying. The nutritionists refer to their recommended dietary allowances, RDA, by saying that these are the amounts that will prevent most people from developing the corresponding deficiency disease. Most people in ordinary good health. What they should say is it will prevent most people who are in what is ordinary poor health from dying of the corresponding deficiency disease. To be in what ought to be ordinary good health, they need to be ingesting the optimum amounts, the proper amounts of these valuable substances. Next slide. There's an interesting difference between vitamin C and the other vitamins. The other vitamins, thiamine, pyridoxine, riboflavin, vitamin A, and so on, are required by essentially all animal species. Vitamin C is not required by most animal species. 99% or more of animal species synthesize ascorbate. They do not rely on the dietary sources of the substance. And if I ask why do these animals continue to synthesize vitamin C, even though they may be getting large amounts by ordinary standards in their diet, several grams a day for an animal the size of a man, the answer surely is that they continue to synthesize ascorbate because the amounts they get in their diet are not enough to put them in the best of health, not enough to put them in the fittest condition in the environments in which we live. Next slide. Man is one of the few unfortunate species of animals who are in rather poor health generally because of not having as much ascorbate as corresponds to the best of health. When I looked at 150 raw natural plant foods, taking the amounts that would give 2,500 kilocalories of energy, I found that for thiamine and other vitamins, there was perhaps 3 times or 5 times as much of the vitamin as is now recommended, as you get in modern diet on the average, but 50 times as much vitamin C as is recommended. And I thought this is an indication that larger amounts of vitamin C are needed because animals are getting these larger amounts but continue to make ascorbate. Next slide. The next slide, please. Another interesting fact is that the committee that recommends the diet, the food for monkeys, experimental monkeys, recommends 70 times as much vitamin C. Monkeys also require exogenous vitamin C. They are primates, and all of the primates require this vitamin. 70 times the amount recommended for human beings. I think that this is understandable. Monkeys are very valuable, experimental monkeys. If you've spent months carrying out studies with them and then suddenly your monkeys die, it's a real tragedy. So that a great effort has been made to find out how much vitamin C will put the monkeys in the best of health. No one has gone to the effort to carry out corresponding studies for human beings. Next slide. Well, I mentioned that most species of animals synthesize ascorbate. The amount they synthesize depends on the size of the animal. Small animals produce a small amount, large ones a large amount, proportional to body weight, not to surface area, 2/3 power of the body weight, but to body weight. And the amount produced by different animal species is between 40 and 400 times the usually recommended intake for human beings. Average is 10 grams per day per 70 kilogram body weight. That's why I wrote to Ewan Cameron, to say that 10 grams a day is the amount that he should try. I might say that the pharmacologists sometimes say that 50 milligrams a day of vitamin C per day is a physiological intake, and that 10 grams a day is a pharmacological intake, that the vitamin is being used as a drug. I would say that 10 grams a day is the proper physiological intake, and 100 grams a day might be called pharmacological intake. And people have taken that amount. People have received 125, 150 grams of sodium ascorbate a day by intravenous infusion to control serious diseases without any side effects, and have taken similar amounts by mouth. Next slide. So this is the conclusion that I have reached. I've already stated it. Next slide, please. Well, vitamin C is required for synthesizing collagen, and I think it might well strengthen the normal tissues. Next slide. The reason that it is required is that collagen is formed from procollagen by hydroxylation of prolyl and serine residues. And there are other hydroxylation reactions. This one and other similar reactions do not take place except with use of vitamin C. Next slide. Well, collagen, the value of increased intake of vitamin C under several circumstances has been known for a long time, and surgeons for over 40 years have been recommended in the better surgical textbooks to give all surgical patients a gram or 2 or 3 grams of vitamin C per day in order to facilitate wound healing, healing of broken bones, of burns, to take care of peptic ulcers, periodontal disease. Physicians have known, and dentists too, have known about this. They don't all practice it, but it's been known. Next slide. Here is a reference to Ewan Cameron, my associate for 10 years now in this work, and to his book, Hyaluronidase and Cancer. Next slide. And I argued then in 1971, as stated on this slide, that the increased synthesis of collagen might strengthen normal tissues to a significant extent. Next slide. Since then, a large amount of information has been gathered about the relation between intake of vitamin C and various aspects of the immune protective mechanisms. Valance, Fagan, Yonemoto, others have shown that antibodies, IgG and IgM, are produced in larger amounts with the increased intake of ascorbate. Fagan showed that component of complement involving collagen-like sequences of amino acids, as shown by Professor Porter, is produced in larger amounts. The blastogenesis of lymphocytes occurs at a greater rate, and the activation of cytotoxic macrophages has been shown to be increased. Interferon production is reported to be greater with a greater intake of vitamin C. I might mention that there's been a tremendous amount of interest in interferon for the treatment of cancer. One important point here is that to treat a patient with interferon costs about 1,000 times as much as to treat him with ascorbic acid. Dr. Cameron says to people who ask about interferon, take ascorbic acid and synthesize your own interferon. Next slide, please. This is the only study on vitamin C that's been carried out in the National Cancer Institute of the United States. Yonemoto, Kratian, and Feiniger gave vitamin C 5 grams a day for 3 days to volunteers. The rate of blastogenesis of lymphocytes under antigenic stimulation doubled with this intake. When 10 grams a day for 3 days was given, the rate tripled. And when 18 grams a day for 3 days was given, the rate quadrupled. It's known that a high rate of blastogenesis of lymphocytes in a cancer patient is correlated with a better prognosis, longer survival, than a low rate of blastogenesis. Next slide. Ascorbate seems to have significant prophylactic value. Here I've listed 7 studies relating to vitamin C in cancer. Studies in which, when a number of environmental or nutritional and nutritional factors were correlated with the morbidity from cancer, vitamin C turned out to have the highest correlation coefficient, negative, of course, to be the factor that seemed to be most strongly related to morbidity from cancer. Next slide. An interesting study was carried out by Dr. DeCosse and his associates. DeCosse is now the head of surgery in the Memorial Sloan Kettering Cancer Center in New York City. He found that 3 grams a day of vitamin C given to patients with familial polyposis caused the polyps to disappear in half of the patients. I've suggested that he give 10 grams a day in the new trial, which is underway, but he is sticking with 3 grams a day because of his worry about toxic side effects of large doses. Well, there just aren't any toxic side effects of large doses of vitamin C. Talk about kidney stones has essentially no basis whatever, no cases in the medical literature. Damage to the liver doesn't occur, although it's sometimes mentioned without references. Next slide, please. Bruce in Toronto has used the Ames method of testing for mutagens to study fecal material, the contents of the lower intestinal tract. There are many mutagens that show up, and they, of course, when tested with much difficulty, various mutagens for carcinogenic activity have usually been found. 90% of them have been found to be carcinogens as well. When vitamin C is given by mouth to patients, the number of mutagens in the fecal material is much less. This is presumably a mechanism for preventing cancer of the lower gastrointestinal tract. I find when I take 10 grams a day, which is the amount that I do take, that half of the vitamin C, 5 grams, remains in the contents of the gastrointestinal tract, presumably then providing protection against this tract. And in particular, of course, preventing the formation of nitrosamines, which are a cause of gastric cancer and other cancers, but also destroying other mutagens in the material in the gastrointestinal tract. 5 grams gets into the bloodstream. Of this, 30%, 1.5 grams, is eliminated in the urine and provides protection of the urinary tract on the way out. And the other 3.5 grams works throughout the human body. Next slide. Here are some clinical tests, all that have been carried out, that have been reported as yet. I made a mistake when I wrote the copy for this slide. Cameron's last study involves 300 terminal cancer patients treated with ascorbate compared with 2,000 matched controls in the same hospital. With these studies, 100 against 1,000 matched controls, there was essentially random distribution of patients between Dr. Cameron on the one hand and the other surgeons and physicians in the same hospital on the other, over a period of time when Cameron was giving the patients with terminal cancer, untreatable cancer, vitamin C, and the other surgeons and the physicians were not, so that we had a sort of randomized allocation of patients to the two groups. Morishiga and Morata are associates of our institute in California. Murata has worked there 2 summers, and their work is carried out in a hospital in Japan. Next slide. The first thing that Dr. Cameron and his collaborators, the surgeons working with him, noticed was that the patients feel better when they receive ascorbate. Cancer patients usually are pretty miserable, don't feel well, they have poor appetites and don't eat well. These patients lost their cachexia. They began to feel lively, feel well, have good appetites. And then there were other responses that were noted. And later on, of course, it was found, next slide, it was found that they survive longer than the controls. And this slide shows survival times of the 100 patients with untreatable cancer who received ascorbate and the 1,000 matched controls, 10 matched to each of the ascorbate-treated patients who had also reached the untreatable stage when no therapy was administered to them except morphine or diamorphine to control pain. After the date of untreatability, the controls lived on the average 54 days, and the ascorbate-treated patients lived on the average about a year, much longer. And of the controls, only 3 in 1,000, 0.3%, survived over 400 days. 0.4% over a year after untreatability, whereas there were 16% of the ascorbate-treated patients who continued to survive. And these patients continued to survive for a long time, as much now as 8 years after having been considered to be terminal with an expected survival time of only a couple of months. Next slide. These are results of similar observations made in Fukuoka Torikai Hospital in Japan, Fukuoka, Japan. Again, there's a low ascorbate group receiving less than 5 grams of vitamin C per day. In Cameron's patients in Scotland, the low ascorbate group received very little, perhaps 50 milligrams a day, and the high ascorbate group receiving more than 5 grams a day, average of about 15 grams a day. The curves, the survival curves, are essentially the same as for the study in Scotland. The next slide. These graphs represent a breakdown of that comparison of the first 100 ascorbate-treated patients in Scotland and the 1,000 matched controls. Here we have 17 patients with cancer of the colon who had reached the untreatable stage, compared with 170 matched controls. And the controls died off pretty rapidly. The ascorbate-treated patients lived on, a number of them here, a third of them or more, over a year. One of them was still alive in 1978. With cancer of the stomach, bronchus, and breast, the situation is rather similar. Next slide. Cancer of the kidney, rectum, bladder, ovary. There doesn't seem to be much difference in the response of patients with different kinds of primary cancer to ascorbate. There are some statistically significant differences, but it's a difference between living a year longer on the average and living 7 months longer. In general, I would say these patients who have reached the untreatable stage, and in Scotland, the untreatable stage for patients, adult patients with solid tumors, gastrointestinal tumors and so on, do not receive chemotherapy, so that these patients in general had not been treated with chemotherapy. In general, I would say that the evidence indicates that to give them ascorbic acid leads to greater survival time as well as better well-being during the period of survival than treatment with chemotherapy does, the standard sorts of chemotherapy that are used now. Next slide. Another trial carried out was by Cregan, Mertel, and others in the Mayo Clinic. The difference between that trial and the trials in Scotland and Japan is that 88% of the patients, 123 patients in the Mayo Clinic trial, had received chemotherapy. Only 4% in Vale of Leven Hospital. We argued, Dr. Cameron and I, before the Mayo Clinic trial was begun, that they should not use patients who had had their immune systems badly damaged by courses of chemotherapy, because of our feeling that vitamin C works largely by stimulating production, by stimulating the immune system. Next slide. Well, our conclusions, with the possible, and I just quote from our book, the last sentences in our book, Cancer and Vitamin C, with the possible exception of during intense chemotherapy, we strongly advocate the use of supplemental ascorbate in the management of all cancer patients from as early in the illness as possible. Next slide. We believe that this simple measure would improve the overall results of cancer treatment quite dramatically, not only by making the patients more resistant to their illness, but also by protecting them against some of the serious and occasionally fatal complications of the cancer treatment itself. Next. We are quite convinced that in the not-too-distant future, supplemental ascorbate will have an established place in all cancer treatment regimes. Next slide. Now, the advantages. It is an orthomolecular substance. Every human being has vitamin C in his body, so long as he continues to live. Has very low toxicity, no serious side effects, makes the patients feel much better, very low cost. It's compatible with most or all other methods of treatment, the exception being chemotherapy. Of course, I think that chemotherapy should be used with childhood cancer, leukemia, Hodgkin's disease, possibly together with vitamin C. But my own feeling is that vitamin C for adults with solid tumors is probably preferable to chemotherapy. Well, I can end up by saying that in the United States, the medical profession as an organized group has not accepted these ideas. Individual physicians, I would judge, have, because we get hundreds of letters and telephone calls from individual physicians who have developed cancer, asking for more information. Thank you. For a number of years, I have thought that there should be people who might be said to practice theoretical medicine. There are thousands of theoretical physicists, and they have, of course, made important contributions to science, and hundreds of theoretical chemists, some theoretical biologists. Why shouldn't there be people in the field of theoretical medicine? My experience has indicated that many workers in medicine and such fields as nutrition are not able to understand and appreciate theoretical and rational arguments. Cancer is one of the most important causes of human suffering. People die, of course. They get old and in the course of time die. But the amount of suffering associated with death is different for different causes of death, and in fact for different ages. Death at an advanced age very often involves considerably less suffering for the person himself and for members of his family and others than death at an earlier age. If we could increase the length of life so that more people died at an advanced age and could eliminate cancer, an especially unpleasant way of dying, then there would be a decrease in the amount of human suffering. I read a book by a man, Dr. Ewan Cameron, of Scotland a number of years ago. The book was published in 1966. Its title is Hyaluronic Acid and Cancer. He pointed out that not very much progress was being made in the attack on cancer by producing anti-cancer drugs and changing the ways of irradiating a person with high-energy radiation. In fact, the National Cancer Institute has spent billions of dollars, thousands of millions of dollars during the last 20 years. $800 million is its budget this year, and yet the mean survival time of cancer patients has changed very little. For a few percent of these patients with certain rather special kinds of cancer, there has been a significant improvement. But for the great majority, more than 95% of the patients who have important kinds of cancer, there's been essentially no change as a result of all of the effort, all of the expenditure of money. Cameron, in his book, said that perhaps an effective way of attacking the problem of cancer would be to bolster up the body's natural protective mechanisms. Almost every cancer patient after surgery, when the primary cancer is removed, has millions of circulating malignant cells. And yet, not every one of them develops metastases. In many of them, these circulating malignant cells seem to be kept under control. This is, with little doubt, the result of an effective immune surveillance. The body's natural protective mechanisms succeed in getting control over the malignant cells, and the patient does not succumb to cancer. Cameron mentioned that malignant cells, many kinds of malignant cells, produce the enzyme hyaluronidase, which then attacks the hyaluronic acid in the intercellular cement of the surrounding normal tissues and weakens these tissues in such a way as to permit infiltration by the malignant tumor. And his book, in his book, he went on to express the hope that some way could be found to stimulate the production by the patient of an increased amount of physiological hyaluronidase inhibitor, which would inhibit the action of the hyaluronidase and in this way protect the surrounding tissues and permit the tumor to be brought under control. For a number of years, he tried to find some such way by giving to terminal cancer patients various hormones and mixtures of hormones, thinking that sooner or later he might find a hormone that would stimulate the production of a hyaluronidase inhibitor. And year after year, he was disappointed. The patients with terminal cancer died at just about the rate the standard rate. There was no effective treatment of this sort. I was asked in 1971 to give a talk at the dedication of a new laboratory for cancer research at the University of Chicago, the Ben May Laboratory. In fact, Tiselius had been asked to give this address and had agreed to come, but a week or 10 days before the occasion of the dedication, he sent a telegram saying that he was ill and was not able to come. So the organizers, the people at the Ben May Laboratory, called me and asked if I would come and speak. I needed to say something about cancer, and so I presented an argument as follows. We know one thing about ascorbic acid, and have known for 40 years. That is that collagen, the principal component, proteinaceous component of connective tissue, is not synthesized except in the presence of ascorbic acid. Ascorbic acid is required for its synthesis. The intercellular cement in tissues contains not only these glycosaminoglycans, hyaluronic acid, and long chains, but also long fibrils of collagen, which act like the reinforcing rods in reinforced concrete. They help to strengthen this intercellular cement. And so I said that I thought that if patients were given more ascorbic acid, this would strengthen the normal tissues and help to bring the malignancy under control. Cameron read a newspaper account of my talk and wrote to me asking how much ascorbic acid they ought to be given. And I wrote back saying 10 grams per day. He began cautiously giving 10 grams per day of ascorbic acid, actually sodium ascorbate, at first for about 10 days intravenously and then orally to these patients, and immediately developed the feeling that this was beneficial to the patients. Another argument had been presented at about the same time by Douglas Rothman, who wrote to Cameron saying that perhaps ascorbic acid units are part of the hyaluronidase inhibitor, and perhaps ascorbic acid in large amounts would permit the patient to develop hyaluronidase inhibitor. Well, now, of course, we feel that there are many ways in which an increased intake of ascorbic acid operates to potentiate the body's natural protective mechanisms, and perhaps these two that I've mentioned are not the most important ones. The fact is that it is a matter of observation that patients who receive a good intake of ascorbic acid have a much better prognosis than those who receive just the ordinary intake or less than the ordinary one, because, of course, most cancer patients are malnourished anyway, with respect not only to ascorbic acid, but to other nutrients. The reason, perhaps I should say why I said 10 grams per day. But first, let me say that it has been a surprise to me to get involved in cancer research. I didn't intend to do it. I was working years ago in the field of immunology for a while. And then I had the idea that there could be diseases that could be described as molecular diseases. Sickle cell anemia was the first disease characterized in that way when it was found that the hemoglobin molecules that patients with this disease manufacture differ from those manufactured by other people. And we found, and other people very quickly found, a number of other abnormal human hemoglobins. The total number known is somewhere around 300. The study of the hemoglobinopathies has extended greatly. I decided, after 8 years of working on the hemoglobinopathies, to look at other diseases to see to what extent they were molecular diseases. And I thought they might as well be, it might as well be some important disease. The choice seemed to me to lie between cancer and mental illness. I decided to study mental illness rather than cancer, with the argument back in 1953, this was, the argument that almost everybody works on cancer, practically nobody works on schizophrenia and other mental diseases, so there wouldn't be so much competition in that field. And I worked for 10 years on schizophrenia, and at the end of that period, toward the end of that period, I ran across work by Hoffer and Osmond in Canada on the treatment of schizophrenic patients by giving them large doses of vitamins, in particular of nicotinic acid or nicotinamide. I was astonished to read what these investigators reported. They were giving, let's say, 17,000 milligrams a day of nicotinic acid to schizophrenic patients, whereas 17 milligrams a day is the amount recommended by the Food and Nutrition Board of the United States National Academy of Sciences National Research Council to prevent pellagra and to keep people in what the Food and Nutrition Board calls ordinary good health. I call it ordinary poor health. Also, I found that Milner had carried out a double-blind study with schizophrenic patients to see what the effect of a large dose of ascorbic acid was. And he found a statistically significant effect, that a large intake, not very large, a couple of grams per day of ascorbic acid, caused the schizophrenic patients to improve much more than the controls who received a placebo. As I thought about this matter, I realized that one might formulate a general principle, which is that there is a concentration of each vital substance that corresponds to the optimum health. This is not necessarily the concentration, the intake, that prevents overt manifestations of deficiency disease. It may be very much larger than that. In fact, there is no reason, I think, to say that only the vitamins are important as nutrients. A vitamin is described as an organic compound that in small amounts is required for life and good health. And in the case of ascorbic acid, if we don't get any ascorbic acid, we die of scurvy. The connective tissue just falls apart because collagen is not being synthesized. The joints fall apart and the walls of the blood vessels fall apart. You have internal, intramuscular bleeding, all sorts of manifestations, ultimately leading to death, manifestations of degradation of the connective tissue, the collagen. Well, it might be that even without ascorbic acid, enough collagen could be synthesized to keep people from dying. And then ascorbic acid would not have been called a vitamin. And still, the various effects that it has could be very important for good health. I don't think that it is essential that a substance be a nutrient, be a vitamin, in order for it to have great importance. But of course, ascorbic acid is a vitamin, and it's the one that I shall talk about most today. The question comes up, why should I have recommended 10 grams a day? Well, that seemed a sensible and safe recommendation to make. You know, we can ask, Why is it that all plants manufacture thiamine, vitamin B1, and animals do not manufacture it? They require it exogenously. The answer is that back several 100 million years ago, a plant began running around and eating the other plants and called itself an animal. It was eating its immediate ancestors. And they manufacture thiamine and other vitamins. And so it was getting in its food. It wasn't like the red bread mold that requires only biotin exogenously and can synthesize everything. This animal, it could synthesize ascorbic acid, and the plants were making ascorbic acid, or thiamine, were making thiamine. It got enough thiamine in its food. Well, there is a general basic principle in biology that if you don't need a function, then the gene responsible for it disappears. And the reason for that, of course, is that it becomes a burden. So when a mutant arose which no longer had the genes that synthesized, then there are a lot of them involved, about 16 perhaps, that synthesize the enzymes that convert other materials into thiamine, the pyrimidine half and the thiazole half, and the enzyme that hooks these two together. When the animal, a mutant, arose that had shuffled off this machinery, then he was streamlined. He was not burdened the way the wild type was, and consequently the wild type died out, and this ancestral animal, from then on, he and all of his descendants have required exogenous thiamine in order to be in good health. And this happened for riboflavin and for nicotinic acid and for pyridoxine and vitamin A, the other vitamins. All animals require these substances exogenously. This is an indication, too, that the needs of animals for these substances are about the same as for the needs of the plants. But it didn't happen for ascorbic acid. Practically every animal species, as a very good approximation, you can say every animal species has continued to manufacture ascorbic acid. Why didn't this ancestral animal give up the mechanism for manufacturing ascorbic acid? The answer is clear. The amount that the animal was getting in the food was not enough for good health. Consequently, and we can perhaps understand it, plants don't manufacture collagen. They rely on cellulose as the structural high energy, high molecular weight molecule rather than on collagen. So that this may well be, this is perhaps as part of the process of changing from being a plant to an animal, that you make great use of collagen and require larger amounts of ascorbic acid. Animals have continued to manufacture ascorbic acid. Man had a bad accident, the precursor of man, in fact, the common precursor of all the primates, had a bad accident, that of living in too good an environment around 25 million years ago. This environment, no doubt, was in a tropical valley where the food was especially rich in ascorbic acid. If he weighed 70 kilograms, or if we convert to 70 kilograms body weight, there are foods that for 2,500 kilocalories or 10,000 kilojoules of energy, food energy, can provide as much as 10 grams of ascorbic acid per day. And this was close enough to the optimum to permit the mutant who had lost one enzyme involved in the production of ascorbic acid to shuffle off this, to get rid of this ability and to compete successfully with the wild type so that he'd replaced him. And since then, all of the primates have been in a bad way. Most of them have restricted their habitats to the tropical regions where a good bit of ascorbic acid is available. Analysis of the food eaten by a gorilla shows that he gets about 5 grams of ascorbate per day. We moved out into temperate and subarctic regions where the food is not so rich in ascorbic acid, and we have been suffering, of course, almost all of us, from hypoascorbemia ever since. If we ask how much ascorbic acid do animals manufacture, animals over a 10 million-fold range of weight, body weight, from the housefly up to the goat, say. I don't think anyone has studied the elephant in this respect. We find that the average amount manufactured by these animals is about 10 grams per day, per 70 kilogram body weight. And this is then one of the reasons for saying that this is reasonable amount to try to see to what extent it will control cancer. You could use much more. Patients are being given as much as 100 grams a day and have taken, I think, as much as, I've heard, as much as 400 grams a day without any difficulty. There are thousands of people who have taken several grams a day for years with no overt manifestation of serious side effects, kidney stones and things like this that are talked about in the medical literature without any sound basis for the suggestion. But 10 grams a day is an amount that it is easy to take. I mentioned the goat. I have, let's see, here in this test tube, which essentially full, 13 grams of ascorbic acid. This is the amount that the goat manufactures each day. And would the goat manufacture this if he didn't need it? I don't think so. This basic general principle would operate. If he were to cut down from 13 grams to 12 grams a day, he would save 7% of the wear and tear and energy required to manufacture ascorbic acid. And if that extra 1 gram weren't beneficial, why not? Why shouldn't he be saving that effort? So I think 13 grams a day for a 70-kilogram goat is probably somewhat less. Well, I won't say probably, is somewhat less than the optimum amount. And of course, he gets a couple of grams a day in his food, too. In this other test tube, I have the amount that a human being manufactures. That's 0. So far as is known, no human beings manufacture ascorbic acid. It's very hard to get back the gene, the ability only by transfer of the gene from some other animal. I understand that human chromosome is found in cats of one kind, sort of European cat, and that it's been introduced into the complement, the genetic complement of that animal, but it's hard to get back. Only microorganisms can develop, and under special circumstances too, can develop its abilities. In this other test tube, there's a little bit of white powder down in the bottom. That's the 45 milligrams per day that the Food and Nutrition Board in the United States recommends for human beings. It's enough to prevent essentially all people from getting scurvy, but it is far too small an amount to put people in good health. I think the goat knows more about these matters than the Food and Nutrition Board. In fact, there's another committee of the National Academy of Sciences National Research Council that I think knows more too. This is the Committee on the Feeding of Laboratory Animals. They have made recommendations about monkeys. Monkeys are primates like ourselves, and they recommend a diet with somewhere around 4 grams a day per 70 kilograms of monkey. Well, now, monkeys are expensive, and moreover, you may you might sometimes build up an automated colony of monkeys. It would be very expensive, and the monkeys themselves you'd paid a lot for, and you put in a lot of effort to inject the monkeys and do whatever is involved in the experiment, and then they die on you. That's a tragedy. So this committee has gone very carefully into the question of what amount of ascorbic acid will put the monkeys in the best of health. And I think I have more confidence in their conclusion that 4 grams a day per 70 kilogram body weight is better than 45 milligrams a day. Well, if we do take the proper amount of ascorbic acid and potentiate our natural protective mechanisms, we might well be able to achieve a considerable control over cancer. I think I might show my slides and amplify the argument as we go on. First slide, please. Here is a curve that I drew, showing that with this vital substance such as ascorbic acid, your well-being might increase linearly for small amounts, small increased intakes, and reach optimal functioning at some point. Actually, experiments with especially the red bread mold have shown that curves of this sort have very flat tops when you study nutrients or vital substances such as the vitamins, and you get, it's hard to find just where the optimum is. I have an arrow there, the functioning of the fittest strain. This is corrected for the burden of manufacturing the material in case that it is manufactured. It is a place where the slope is just equal, except for change sign, to the straight line, presumably straight line that represents the burden of manufacturing the substance as a function of the amount manufactured. Next slide. In the next slide, I have just the Michaelis-Menten curve, say, chemical equilibrium, A plus B equals AB, which could be enzyme plus substrate combining to form, or the apoenzyme plus the coenzyme combining to form the active enzyme. And if you have a mutant, everybody is a mutant. The average estimate is that of the 100,000 genes that you've inherited from your parents, one has been mutated from that generation to your generation. Everyone has these mutants. There may well be people who manufacture apoenzymes with a decreased combination constant for the coenzyme. If the combination constant is decreased 200 times, then you could, by going to 200 times the concentration of the coenzyme, get the same amount of combination with apoenzyme to form the active enzyme. Well, there are scores of genetic diseases known that involve an abnormality in the combination between apoenzyme and coenzyme. An example is methylmalonic aciduria. Patients with this disease excrete methylmalonic acid in the urine because they lack the enzyme that would isomerize the methylmalonic acid to succinic acid, which would then be metabolized. And this enzyme uses cobalamin, vitamin B12, as a coenzyme. If you give the patient 1,000 times the normal intake of cobalamin, then many of the patients are put into normal health and do not show manifestations of the disease. I think that there are, with little doubt, thousands of diseases of this sort, each one of which could be controlled by a great increase in the intake of a particular vitamin or other coenzyme. Next slide. Here, I borrowed this slide from Irwin Stone, who around 10 or 15 years ago was very concerned about the amount of ascorbic acid that people needed and about the prevalence of hypoascorbemia. It shows various animals have been reported as making between 2 and 20 grams of ascorbic acid per day per 70 kilogram body weight. Next slide. Here we have summarized some reasons for a large intake of ascorbic acid for good health. These animals, the average of raw natural plant foods giving 2,500 kilocalories per day, giving 2,500 kilocalories of food energy is 2 3/10 grams. And I have an evolution argument, which I shan't go into, that the optimum intake is somewhat greater than this figure. The monkey chow I have mentioned. Dr. Yu studied guinea pigs, which, like the primates, had lost the ability to make ascorbic acid, and found that they were apparently in optimum health when they got about 3.5 grams per 70 kilogram body weight. Next slide. I mentioned that ascorbic acid is known to be required for the synthesis of collagen, for hydroxylation of the prolyl and lysyl residues in the procollagen molecule, and it's involved in other hydroxylation reactions. For 40 years, it has been known that a high intake of ascorbic acid is required for good healing of wounds and burns, broken legs, fractures. Periodontal disease. Dentists are in the forefront among medical people in giving patients large doses of ascorbic acid to improve their health. The next slide. Back in 1935, Jungeblut in Columbia University College of Physicians and Surgeons reported that poliomyelitis virus is inactivated by sodium ascorbate in concentrations that can be reached in the bloodstream. Various other investigators have reported the same thing. Next slide, please. I was astonished when I started reading the literature to find how much there is. Here are some of the references, not given in detail, about reported control of viral diseases. The National Cancer Institute is and has been spending $100 million a year for study of viruses in relation to cancer, but $0 for an investigation of ascorbic acid as an antiviral agent. To the next slide. And to the extent that viruses are involved in human cancer, the ascorbic acid may be operating in this general antiviral way. The work of Morishige, who is the senior surgeon in a hospital in Fukuoka, Japan, is interesting. Murata published a paper on it. Morishige had the idea that ascorbic acid would prevent infectious hepatitis, serum hepatitis, from developing in surgical patients who received multiple transfusions, with a chance that the virus is in the blood that is infused. He found, when he made a study with 1,250 patients, that those who got little or no ascorbic acid developed serum hepatitis at what was the normal rate there of 7%, but the 2 grams a day or more is 100% effective in preventing serum hepatitis in 1,100 patients. And now he gives 10 grams a day to all patients in his hospital, all surgical patients and all patients in intensive care that he's in charge of. Next slide. And he has reported, but not with the statistics as yet, that in these other viral diseases too, this high intake of ascorbic acid is completely effective in controlling the viral diseases. Next slide. Antibacterial action has been reported for many years, there are several mechanisms involved. For one thing, it's been known for 40 years that leukocytes are not effective as phagocytes unless they have a high concentration, 20 micrograms per 100 million cells of ascorbate. A recent study by Hume and Wires in Glasgow, 1973, showed that the level was about 25 micrograms per 100 million cells in the ordinary Scots that they investigated. If they came down with some illness, it dropped to about 10. And this is not enough to permit the leukocytes to be effective to have phagocytic activity. 250 milligrams a day also wasn't enough. 1 gram a day, however, did the job. Next slide, please. Let's see. I got that in. I put that in at the last minute and apparently put it in reversed, but I'll tell you, it's upside down too. Perhaps we should change that. Look at this one. At the National Cancer Institute, well, I'll go back to this. Rodney Porter has reported in his study of amino acid composition of components of complement that C1, Q, R, and S are proteins which have collagen-like sequences. Professor George Fagan in Stanford University has carried out these studies. The two curves to the left refer to the C1 esterase component of complement, which consists of these 3 proteins, Q, R, and S. And as would be expected, the guinea pigs with a high intake of ascorbic acid manufacture much more of this complement component than those with a low intake. The next slide. Here we have studies made in the National Cancer Institute, reported last year, just in abstract, by Yonemoto, Kratian, and Feiniger, showing that the rate of production of new lymphocytes under antigenic stimulation is greatly increased in humans who are given 5 grams a day. There's about a doubling of the blastogenesis rate with 5 grams a day, given in fact only for 3 days, and this increase continues for 18 days. They haven't determined what it would be for people with a steady intake of 5 grams per day or 10 grams per day. 10 grams a day gives about a tripling. It's well known that the prognosis for cancer patients is better for those who have a high blastogenesis rate of lymphocytes under antigenic stimulation than for those who have a low one. And these investigators said that these results suggest that ascorbic acid should be tried in cancer patients. They didn't know that Cameron had been doing this for several years. Next slide, please. There's a good bit of epidemiological information about ascorbic acid. In fact, when studies are made of the diets of populations in relation to incidence of cancer of different kinds, it is usually found that the biggest correlation of all is the inverse correlation with intake of ascorbic acid. I've written down some of the papers, mentioned some of the papers in this field. The next slide. There was a study carried out in California, Chopin, Breslau, with 577 older people starting in 1958. They were all 50 years or older at that time, and their death rates were followed. Those with a higher intake, here again the biggest correlation, negative, between death rate and any factor was with the intake of ascorbic acid. Even a bigger effect with cigarette smoking. The subjects who were ingesting the larger amount of ascorbic acid had only 40% the age-corrected death rate of those with the smaller amount. The larger amount was only about 125 milligrams a day. The smaller amount, 25 milligrams a day. We are checking a population now with an intake of between 1 and 2 grams a day, and in a few years, well, there are already some preliminary results. For the first 18 months, that result was only a 30%. In fact, this population wasn't restricted to those between 1 and 2 grams, contained some with a smaller intake. Only 30% to the age-corrected death rate. There was apparently the same decrease in the incidence of heart disease as of cancer and other diseases in these studies. I think that it may well be that the age-corrected death rate could be reduced to a tenth of what it is in the population at present simply by increasing the intake of ascorbic acid and perhaps other nutrients by a relatively small amount. Next slide. And that would correspond to an increase of 20 years or more in the length of the period of well-being. 2 papers have appeared recently on control of polyps of the rectum, which universally become malignant in the people who have this chronic polyposis, and in each case with only 3 grams per day given to the patients. Half of them showed a disappearance of the polyps. Instead of having 40 of them, they dropped to 0 or 2. The next slide. Here we have the first report by Cameron on the first 50 cases of patients with terminal cancer, advanced terminal cancer, called untreatable cancer in Scotland. The statement is made that in 4 cases, the treatment with ascorbic acid was harmful. As I've looked over the data and the case histories, I concluded that this probably is not correct because these patients, the population of 50 or the population of 100, including this 50, died off during the first few days or the first few weeks at a lower rate than the control population. There was really no increased death rate in this first 50. The fact that these patients died during the first 2 weeks, 4 of them, I think, indicated to Cameron and Campbell that the ascorbate was harmful. In all of the other cases, there was benefit, and the benefit was sometimes a rather small amount, a decrease in pain, permitting the patients to be taken off narcotic drugs, or general disappearance of cachexia and anorexia. Patients felt well and had good appetites, began to eat well, and went back to work, and some of them have continued to live. The next slide. Far longer than expected. One patient showed an unusual course, such as to permit him to be described in a separate publication. He had reticulum cell sarcoma, well diagnosed by biopsy, and X-ray diagrams showed that this disease was there. When he received 10 grams a day of ascorbate, he improved very rapidly, as shown by these measures of illness. A decreased sedimentation rate of red cells was observed, and glycosaminoglycan serum zeromucoid decreased rapidly. After 6 months, his physician took him off the vitamin C, 10 grams a day, with the argument that he was cured. no signs of disease anymore, so he shouldn't continue taking the drug. Well, of course, vitamin C isn't a drug, it is a food, and he was taking the amount that probably is just appropriate to human beings. If they were manufacturing it themselves, the amount they would manufacture. He took him off the vitamin C, and within a month he was back in the hospital. The cancer had returned. It didn't respond to 10 grams per day orally when it was resumed for a couple of weeks, but he was given 20 grams a day for 10 days intravenously, and immediately improved in health. And he has lived now for several years, getting 12.5 grams a day orally, and driving his lorry back and forth, apparently in perfect health. Well, it's good health, perhaps even better than you expect for people 50 years old living in Scotland. The next slide shows the results of a study of 1,100 patients with terminal cancer, 100 of whom received 10 grams of ascorbate per day, beginning on the day that they were pronounced untreatable. This may occur at laparotomy when the cancer is observed to be of such a nature that it is inoperable, or later after high-energy radiation treatment or cytotoxic drugs have led to have been tried and perhaps had some temporary value, but are no longer effective. The matched controls, 10 matched controls for each of the 100 ascorbate-treated patients, had the same kind of cancer, and the survival times are measured again from the time when they were considered untreatable. 50 times the fraction of the ascorbate-treated patients lived more than a year. The 16 out of 100 of the ascorbate-treated patients are alive after several years, as much as over 5.5 years now. The average survival time now is more than 5 times the average survival time of the 100 controls, the 1,000 controls. The 1,000 controls have all died by this time, with only 15 out of 1,000 living more than 1 year. No, only, yes, I think 15 is right. Only 3 lived more than 400. 3 out of 1,000 lived more than a year. It's marked as 400 days there. Now, several hundred patients with cancer are receiving 10 grams per day in Vale of Leven Hospital in Scotland, and they begin to receive it immediately that they come to the hospital, no matter what the stage of development of the disease is. I could go on and mention some individual cases, not only in Scotland but also in California, but this is the only quantitative material that I have. I think that every cancer patient should be put on ascorbic acid therapy. What the relation is to the cytotoxic drugs has not yet been carefully studied. In California, patients who are receiving 5-fluorouracil or methotrexate or other cytotoxic drugs have been given ascorbic acid also, 10 grams a day. And one observation has been made in practically every case: the serious side effects of loss of hair and nausea, other side effects of the cytotoxic drugs, do not show up when vitamin C is given. On the other hand, it may be that these two treatments operate against one another. The cytotoxic drugs have the side effect of destroying the body's natural protective mechanisms, and the vitamin C operates by potentiating the body's natural protective mechanisms. If you knock out the immune system down to 0, a 10-fold or 100-fold potentiation still leaves it at 0. In the course of time, it will be possible to say what should be done when a choice arises between taking cytotoxic drugs or taking vitamin C. But there is reason to believe that whether or not these other treatments are used, the vitamin C should be taken. Well, this is the situation now. I haven't found anything in the cancer literature during the last 20 years that is comparable to this. To what extent it will stand up, whether you can have a 5-fold increase in life expectancy for people at the beginning stages of cancer who might have a 5-year life expectancy that would be increased to 25 years with ascorbate or not, I don't know. I do feel strongly that cancer and ascorbic acid are closely related. It may be that cancer is in large part one of the manifestations of vitamin C deficiency, that people develop cancer because they are in poor health because of the extremely small amount of ascorbic acid that they ingest. Of course, I have read statements that chemicals which have been introduced into our environment, in our food and into the environment generally, are responsible for a large fraction of the cases of cancer that develop. Ascorbic acid is known to be a detoxifying agent for almost all substances, and perhaps it can work, or does work, as a prophylactic agent by helping to counteract the effect of these cancerogenic substances. I think that this opportunity of helping to control cancer by the use of the proper amount of ascorbic acid, both prophylactically in people who have not yet developed cancer and therapeutically in those who have, is so important that it should not be neglected by anyone. Thank you.